Hello everyone, welcome to another video. So today we create a second project on NLP. So first of all, we understand the problem statement here. So our problem statement is email spam detection using natural language processing with Python. So mobile messages is a way of communication among the people, and billions of mobile devices users exchange numerous messages. However, such type of communication is insecure due to lack of proper message filtering mechanism. One cause of such insecurity is a spam, and the spam detection is a big issue in the mobile message communication, due to which mobile message communication is insecure. In order to tackle this problem, an accurate and precise method is needed to detect the spam in mobile message communication. So here we will create the application of the natural language processing based spam detection method for accurate detection. So this is our problem statement. So this is our project flow. First is a problem statement. Second one is a data gathering. So here we read the data from the input files. Third step is a data pre-processing. So in the data pre-processing, here we perform some operations on the data like tokenization, lowercase, stopwords, lemmatization, and stemming. After that, we performed vectorization. So vectorization means we convert the text data into the vectors. So here we have the two options. First one is a bag of word, which is called as a CountVectorizer as well. And second one is a TF-IDF, term frequency inverse document frequency. So in our project, we use term frequency inverse document frequency. After that, we build a model. Building a model, our first step is model object initialization, and after the second step is model training. So once the model is built, then we evaluate our model based on the some parameters like accuracy score, confusion matrix, and the classification report. So once our model evaluation is done, then we can go for the model deployment. The last step is prediction on the client data or user data. So this is our complete flow for this project. Now first we import all the required libraries. First we import pandas, numpy, as well as the regular expression library. After that we require NLTK library. From that NLTK we require two more functions. First one is the stopwords, and second function is required to create a lemmatization object. So first we input library for the stopwords from nltk.corpus import stopwords. The second one from nltk.stem import wordnet lemmatizer. After that we require some functions from the sklearn library. So first we import the train test split library from sklearn.model selection import train test split. From sklearn.metrics import. So here we require the three metrics we check for the model evaluation purpose. First one is accuracy score. Second is require confusion matrix. And third one is a classification report. After that we require TF-IDF vectorizer. For that we import from sklearn dot feature extraction dot text import TF-IDF vectorizer. To build a model, so in this project basically we build a model by using the Naive Bayes algorithm. So from the Naive Bayes also we use here multinomial Naive Bayes. To import those model we require from sklearn dot Naive Bayes import multinomial NB. From sklearn dot pipeline import pipeline. So why we require this sklearn dot pipeline import pipeline function? So basically in this project we create a pipeline where we pass vectorization and the model building in a single cell. So once we execute this, so now our required libraries are imported. So most of the time when we explain the project to the interviewer, then what happened? We are not able to recall like which function is available in which library. For example, if you see in the sklearn library, we import too many functions. Okay, so if we are not able to recall like trend test split is available in which library for, of the sklearn or which model, so at that time we do the one more thing here. Okay, like we first import the sklearn here. Okay, and after that we just print directory and we pass here those library sklearn. Okay, so if we just print the directory, so now here we easily identify like the model selection is the model is there. So under that model selection we have this trend test split. Okay, if we just print model selection, okay, sklearn dot model selection here. Okay, so under that model selection also we have too many functions. Okay, so here we have the trend test split function. Okay, so at that time you can ask the interviewer, can I print a directory? So most of the time interviewer allow you. Now our first step is a data gathering. To read the data, we already imported the pandas library and read the data using pd.read underscore csv. So first of all we see the data. So in this folder, if you see SMS spam collection input file is available. Okay, if you see here data in the file is tab separated. Okay, so here basically ham and spam there is one feature is available and second feature is the messages is available. So we must provide the separator parameter and also the file does not contain any column names. Okay, so we should provide the column names using name parameter. So we create one variable df pd dot read underscore csv. Here first we pass the file name. Okay, so this file is a tab separated. That's why if we just check the parameters for this read underscore csv, just press shift plus tab. If we check here, here is the parameter separator. Okay, we use here this separator parameter as well as for the feature names we use this names parameter as well. First we use separator parameter and names is equal to, here we pass the column names. Okay, so if we see the data, so first is available ham or spam. Okay, so this is our label data and second one is a message. So we pass here first label and second we pass message. So basically this data is stored in the data frame df. To view the first 5 rows of the data, we should use df.head function. So we can see here that the first column contains the labels, which is called as a dependence variable, that is message spam or ham, and the second column contains the actual message, which is called as the independence variable as well. So once we read the data, our next step is data analysis, or EDA we can say, exploratory data analysis. So we use first information function, data frame.info function we use. So we can see here first column contain label and second column contain the messages, and there are total 5572 messages are available, and both the columns having non-null value. Now we check here, to check the null values we have one more function like df.isNA.sum. So if you see here, there are no missing values in the data. Now we check the target variable count. Target variable is nothing but our this label data. So we just read df of label, and here use one function values count. So this values count function help to return the total count for each category, that is ham and the spam. We can see that the ham messages are more than spam messages. We see that 4825 out of 5572 messages, or 86%, are ham messages. This means that any machine learning model we create has to perform better than 86.6% to beat random chance. Or here we can see our data is imbalanced data. So once the data analysis is done, then we can move to the third steps, data pre-processing. If you see the data, messages contain text but with many punctuation, stop word, special character, and many forms of verb. Now we will clean messages by removing the unnecessary string. So here we will perform tokenization, lowercase, remove stop words, and the lemmatization operations to pre-process the data. In the fake news classification project, we already cover all these operations in detail. If you haven't watched the fake news classification project video, please watch for a better understanding of the concept. So we already imported here regular expression library, and also from the analytical library we already imported stopwords as well as wordnet lematizer, and we create an object for the wordnet lematizer. So first of all we create a empty list which is called as a corpus. Okay, now we will iterate through every messages. Okay, for that we use for loop for data or for I in range length of df. So here basically we use for loop, and here we use the range function. So one by one we iterate all the data. So here we use a for loop. So in that for loop we use the range function. So our length is df is 5572, means our for loop is executed from 0 to 5571 times. Okay, so now we will iterate through every messages, and by using the regex substitute method. To first create a review variable, review is equal to re.sub. Here we pass pattern. So our messages are available in the messages feature or column. See here we pass df of messages, pass here the I value. So what happen if we check df of message of 0, because our for loop is executed for range 0 to 5571. So first we check the df of message of 0. So here we access first message. Like that we iterate all the messages. So what is the use of this re dot substitute method? So in the regular expression this substitute method is there. So we will take everything from the message except small alphabet, capital alphabet, and substitute it with a this blank space. Next we will lowercase the messages. Okay, why we perform this operation? So basically this ABC and this ABC is not the same. Okay, if you see here the meaning is same for both the words, but if you see this ABC is start from small letter and this ABC is start from capital letter. Okay, to machine it is very difficult to understand. To make learning easy for the machine, we use a lowercase operation. So that's why we use review dot lower function. So in the string, lower function is available to convert all the data into the lowercase. And after that, split into the words, or we generate a word tokens. To generate a word tokens, we use here review dot split function. By using the split function, we split our sentences into the words or we generate a token. So once the tokenization is done, then we will check each word that whether it existing in the stop word collection or not. So basically here we perform now stop words removing operations. So for that we use a list comprehension method. So first we access all the data available in the review, and here we use if condition. If those data means X not available in the stop words dot words of English. Okay, in the last project also we saw this. Okay, if we execute this stop word dot words of English, okay, so here we will get all the stop words which is available in this NLTK library. So once stop words remove operation is done, now we will apply lemmatization on that data. So here again we use a list comprehension method. Okay, so first of all we need to create a lemmatization object. So here we create lm is equal to word net lemmatizer, and we pass here lm dot lemmatize, and we pass here those data. Okay, so instead of X I mention here data. So once each word is lemmatized, then we can go for the join operation. So here we again join all the words and form a sentence. So for that we use in the string there is one function is a join dot join, and here we pass the data. Now we append final pre-processing output into the corpus list which we already created. So in the list there is one function is there append. With the help of this we append all the pre-processing final output into the corpus list. So in this corpus list now clean messages are available. If we execute this, okay, now if we check the our length of these messages is 5572. Okay, and if we check the length of our corpus list, okay, it's also the 5572. Means what? We pre-process all the messages. So what we do now, replacing the messages, all these messages with the clean messages that is available in the corpus. So once you execute this, if you see here in our data clean messages are available. Our next step is model building. So here first we perform data splitting. So first of all, we create X and Y label. So here we splitting a data into X, which contain the independence variable, that is messages, and Y include the dependence variable, or we can say the target variable, that is include labels, spam or hem. So in the messages, DF of messages, all the messages are there, and in the DF of label, all the labels are there, like ham and spam. So once we create a X and Y label, then we split the data into the training and the testing data. So for that we use train test function from the sklearn library. So if you see here, we already imported from the sklearn.model selection import train test split. So first we call this function, and here we need to pass first X and Y data. After that, here we need to pass one parameter, test size. So here we mention test size is equal to 3, and the random state, here we selected random state as a test. Okay, so why we pass here the random state parameter? So basically, whenever we run this function, every time we get the same data. Okay, that's why we pass here the random state parameter. If the random state parameter is not passed here, then what happens whenever we run this statement? So every time we will get different data. Train X test, Y train, and Y test. So here I split the data into 70% for the training data and the 30% for the testing data. See, if we check the length for X train versus length for Y train, so it should be the same. Okay, so whenever we train test split function we use, so at that time we need to check this length. Okay, so most of the time what happen, this sequence is wrong. Okay, so sometimes we wrote like X train, Y train, X test, Y test. Okay, to verify this the sequence, we check this length every time. Same we check for the X test and Y test data. Okay, this length is also equal. So our next step is vectorization. So here we convert text data into the vectors. So why vectorization is required? We can't directly pass the text to the machine learning model, as the machine only understands data in the form of zeros and ones. To solve this problem, we will use the concept of TF-IDF vectorization. TF-IDF is nothing but term frequency inverse document frequency. It is a standard algorithm to transfer the text into a meaningful representation of numbers, and is used to feed the machine algorithm for prediction. So here also we use TF-IDF vectorization from sklearn library. Okay, so we already imported TF-IDF vectorization from the sklearn library. So first we create an object for that, TF underscore object. Okay, here first we create a object. Okay, so once the object is created, then we feed the data which we'll want to convert into the matrix of word and sentence. So once the object is created, then we use fit underscore transform, which will convert into a matrix of word and sentence. Here we pass xtrain data. To store these values, we create here one variable xtrain, and we give the name as a TF-IDF for easy understanding. If we print this data, okay, so here we need to convert it into the array as well. So we convert xtrain data into the vectors. So if we check the shape of this data, 3900 are the sentence of the xtrain and 6931 are the total words obtained from the sentences. Now we create a pipeline. So here now we are doing the pipeline, as we need to perform the same procedure for the test data to get the prediction. Okay, so basically in the previous project, fake news classification detection, once our data pre-processing is done, then we can go directly for the vectorization, and once the vectorization is process is done, then we can go for the data splitting into the training and testing, and after that we create a model object. But here we create a pipeline. That's why initially we import the pipeline function from the sklearn.pipeline. So if you don't know about the pipeline, so basically it takes a list of tuple where each tuple takes the name set by you and call any method you want to perform. Now we see how to create the pipeline. I have take here the variable name text underscore mnb. So I call here the first pipeline function. Okay, so under that it takes a list of tuples. Okay, so here we create a list, and under that we pass the tuples. So first we pass the name, and after that we pass here method. Okay, so this is our first tuple. We create second tuple for the model training. So here also I pass the name as a mnb. After that pass here multinomial nb. So basically this function or this model we import from the sklearn.naive Bayes algorithm. So this is the naive Bayes algorithm. So here we use multinomial naive Bayes. So basically here we create a pipeline and give the name like the text underscore mnb. So where we first provided TF-IDF vectorizer object and the second multinomial NB object. It should be provided in a sequence, as we want the first TF-IDF vectorizer should be executed and the output of it will be provided to the model. And then by using this multinomial NB, we predict our final output. In this pipeline, we feed the X-train and Y-train data. So however, what is convenient about this pipeline object is that it can perform all these steps for you in a single cell, which means you can directly provide the data. It will be both vectorize and run the classifier in a single step. So when we will predict the custom text later or user data, we can directly pass the custom text to the pipeline and it will be help to predict the labels. So now every internal functionality will be handled by the pipeline and will perform the steps accordingly. Now to make a prediction, we need to pass a X-test data and the pipeline object will handle it. That is automatically vectorized and it makes the prediction for us. Okay. So for that we create an object like y prediction underscore test. Okay, is equal to. See here we call this pipeline dot predict. Here we pass X test date. So first we check the accuracy score. First we call the accuracy score function, which is already imported from the sklearn library, and here we pass actual data. So actual data is our Y test because we take input as a X test. Okay, so Y test, and this is our predicted output. So here basically we compare actual output with the predicted output. So on the testing data, we receive 95% accuracy. It's 95.87 means almost 96% accuracy we receive. Same we check on the training data. Here also we create object y prediction underscore train pipeline dot predict. Here now we pass instead of x test, we pass here x train data because we check the accuracy on the training data set. Here also we print accuracy score. Same we call the first function, and here we pass actual data. So in here now we pass the x-train data. So our actual data is y train and predicted output is y predicted train. So we receive around 98.30% accuracy. Now same we check the confusion matrix and the classification report on the testing data set. So first we check confusion matrix on testing data set. The first line is the same, only changes here. Instead of the accuracy score, we call here confusion matrix. So this is a confusion matrix for the test data. Same, we check the classification. Here we call classification report function and pass y test and y prediction test. So here we receive the classification report. In the previous project, we create a evaluation class for the training dataset as well as for the testing dataset. So we can create the evaluation class as well, or one by one we can check like this. Now here our model building is done. In the model building here, first we split the data, okay, into x and y label. So first we pass here independence variable in the x, and in the y we pass here dependence variable. After that we split this data into the training and the testing. Okay, here we check the length for the x train and the y train. Also we check the length here, x test versus y test. After that we use vectorization to convert the text data into vector. After that we use here the vectorization to convert the text data into the vectors. So here we convert extract data into the vectors. After that we create this pipeline. To create a pipeline, first of all we imported the pipeline function from the sklearn library. So in the pipeline we pass list of tuples. So in the first tuples we pass here TF-IDF vectorizer object. Second tuple we pass here the multinomial NB. So once our pipeline is created here, then we check the accuracy score on the testing dataset as well as on the training dataset. So we receive around 98% accuracy on the training dataset and 95.87% accuracy on the testing dataset. And same we check the confusion matrix and the classification report on the testing dataset. Now what we do here, we predict the user data now. Okay, so one by one we check here. Okay, so first of all, once we receive the data from the user, our first step is a data preprocessing. So here I create a one function preprocess data, and in that we pass the text or data we pass here. Okay, so we already write a code for the data preprocess. Same code I copy here and paste here. Okay, so only the thing is change here. Now here we take the user data. This function return, okay, our preprocessed data. I execute this function. Okay, so let's assume we take df of message. This is our user data. First we print the user data, we apply this function. Okay, so now here we check this function is work properly or not. Okay, first here call this function, and here we pass user data. So this function work correctly. Okay, now what we do, now we have this data. Okay, now we predict our final output. Okay, so we already create a pipeline. Okay, so in that pipeline we pass TF-IDF vectorizer and multinomial. Means what, whenever we pass the data in this pipeline. Okay, so first vectorization operation is performed, and after that use of the multinomial NB we predict our final output. So here we pass user data. I store this preprocessed data into the data. Say the user data. Same preprocessed user data we pass here. So if we see our model is predicted, this message is a harm. Okay. So here basically we receive the array. Okay. If you need only the harm, here we pass the index, 0 index. So we receive as a harm. Okay, now what we do, our code is work. So once we receive the user data, first of all we perform here the pre-processing steps on the data. So once our data is pre-processed, then we can use of this pipeline text underscore mnb dot predict, and here we pass the user data. Okay, so based on that we receive here our final prediction. So what we do now, we create a one prediction class df underscore underscore init underscore underscore. Here we pass self and data is required. Okay, user data is required, and here I have mentioned the self dot data is equal to data. Okay. Now we create a one more function user underscore data preprocessing. So once we receive the data from the user, first of all we need to perform data preprocessing step. Here I have called lemmatization object. I have just copied this code again. So this function is created, user data preprocessing. Okay, now we create a one more function, user underscore data underscore prediction. Here we pass the self. Okay, so whenever we call this prediction class, okay, so what happened, we need to pass the data, user data we need to pass. Okay, so our requirement is on this user data, this data preprocessing need to perform. Okay, but what we do here, so whenever we call this class prediction class, we need to pass the data. Okay, so our object is created. Okay, after that, if we call this prediction user underscore data underscore prediction function, we need to get our final output. So this is our flow basically. Okay, we receive first user data. Okay, so once we receive the user data, then we need to perform data pre-processing on that. Okay, and once the data pre-processing is done, then we need to convert those data in the vectors. So here we use TF-IDF. Okay, so our data is converted into the vectors, then we predict the final prediction. Okay, like the given messages is spam or ham. Okay, for that we use multinomial NB. So this is our flow basically. Okay, so whenever we call this class, okay, we need to pass the data. So this data is nothing but this user data. Okay, after that, what is our requirement? Data pre-processing is required. Okay, so after that, we need to execute this function. By using this function, we perform data pre-processing operation on our user data. Okay, and after that, what is our requirement? We need to perform vectorization as well as prediction here. So what we do here, whenever we call this prediction class, okay, along with user data prediction, our prediction is given. So what we do in this function, so we call this user underscore data underscore pre-processing function under this user underscore data underscore prediction. So in the same class, whenever we call one function to the another function, in that case we use self keywords. I just use self dot call this function, and this output store in this preprocessed data. Now our next step is, once we receive the preprocessed data, we need to predict the final prediction. So basically here data preprocessing output store in this variable. What is our requirement? On that data we need to perform vectorization as well as the prediction. For both this operation we create a pipeline. Okay, so now we call that pipeline. Okay, text underscore mnb. Okay, this is our pipeline. Here we will dot predict, and here we pass pre-processed data, and here we pass the index. Okay, we already saw here pipeline dot predict pass the user data of 0. Here we will get the harm. So if our this output is equal to the spam, then this function return this SMS or this message is spam, else this function return this message is ham. So we take two examples. Okay, first we check the spam messages. Okay, so here I have print df dot head. Okay, so here we print our original data set. Okay, so if we see, first we check the spam message. Okay, so our in the second index the actual output is a spam. Okay, so we just check df of message of 2. This will store in the user data variable. Okay, so here we print user data first. On this user data we perform this prediction. Okay, so first we print the user data. Okay, then we first call prediction class. So whenever we call the prediction class, we need to pass the data. So this data is nothing but our user data dot, we need to call this user data prediction function. Okay, so what is our actual output is spam. Okay, and expected output is also spam. We just check our model is executed correctly or not. There is one change. Okay, instead of this text we need to pass self dot data here. Okay, again we execute. Okay, now if we see here we receive the correct output. Okay, now same we need to check on the harm messages. Okay, user underscore data is equal to df of message. Okay, first we print this user data. Okay, so this is our message. I just copy and paste here. Okay, first we call the class. Whenever we call the class, we need to pass the user data, and in that class we already defined this user underscore data underscore prediction. Okay, so once you execute this, okay, so our actual output is harm and our expected output is also harm. Okay, so we just check here our model predicted correctly or not. Okay, so if you see here, we receive the expected output. This message is harm. Here our SMS spam classification project is done. Same project I have uploaded on GitHub. You can find the GitHub link in the below description. Thank you for watching this video. If you like this video, please like, share and subscribe my channel. Very soon we will upload few more videos related to machine learning and NLP projects. Thank you.